Sorry, you were saying. Okay, let's start with partial fractions. In your O levels, I'm sure you must have seen fractions like 3 upon x plus 2. Yeah? And if I ask you, if I give you 3 upon x plus 2, and I ask you 3 if I give you an expression 3 upon x plus 2 plus 1 upon x plus 1, and I ask you to give the answer as one fraction. Yeah. So what do? You basically take the LCM.
Yeah.
Yeah. So what will you do? You will do x plus 2, x plus 1, which will you multiply 3 with x plus 1 and 1 with x plus 2. Yeah. This is what you do. Then you open up the brackets. 3x plus 3 plus x plus 2 upon x plus 2, x plus 1, and 4x plus 5 upon x plus 2, x plus 1. Yeah, this is what you do. You knew this?
Yeah.
Yeah. So this is the answer what you're getting. Now on this level in P3, what we do is this is what they give us. The answer that you get, this is what they give us as the question now. This is what they will give you as a question, and they will ask you to give your answer in this form. This is a form known as partial fractions. And this is what our answer should look like. This is called partial fractions. Okay? They want you to break up the fraction now. Okay? Initially, they were asking you to give your answer as a single fraction. Now they want you to break the answer and give us multiple fractions. Okay? So there are 3 types of partial fractions that they can ask you. First is the linear form. In the linear form, what happens is the denominator that they give you has linear factors. So they'll give you a question like this: x plus 1, x plus 2, x plus 3. I'm just giving you the theoretical information right now. We'll do the application later, okay? So if it's a linear form, if they have given you a question with linear form, you have to give an answer in the form a upon x plus 1 plus b upon x plus 2 plus c upon x plus 3. Now what's happening is I'm just breaking up the fraction by each factor they've given me. Each linear bracket they've given me, I'm just breaking up the fraction like that. So a upon x plus 1, then b upon x plus 2, c upon x plus 3. If there were more brackets, I would have done D, E, F, G, no matter how many brackets are there, okay? Yeah. All right, okay. The second form that they can give you is a repeated form, which you just discussed with me as well. What happens in a repeated form is basically they will give you a fraction which will have a square on the bracket. Okay? So in a repeated form, there is a square on the whole bracket. Can you see the square?
Yeah.
This is what a repeated factor looks like. So for this kind of a question, you will have to give an answer in the form a upon x plus 1. This will be opened as this. Now the repeated roots, the repeated bracket will be opened like b upon x minus 2. You take it once. And when you do c, you put a square on the bracket. So the repeated, the bracket with the square will be opened with, once it will be opened as a linear form, then a quadratic bracket. Understand?
Yes.
Okay. Now there is a third type they can give you, which is the quadratic form. Now quadratic form is where there is a square on x. Okay. X has a power of 2. Can you see this? This is what
Yeah.
a quadratic form looks like. So how do you open a quadratic form? You do a plus x plus 1 for the linear bracket. Then for the quadratic bracket, you do bx plus c upon x square plus 2. Okay? So whatever I'm opening is depending on the brackets they've given me below. All right? Do you understand the 3 forms?
For the last one, can you explain it? Because
Yes.
again, because I couldn't hear you well.
Yes. So in the third form, basically, you have a linear bracket and a quadratic bracket. A quadratic bracket is basically a bracket with a power, when x has a power of 2. Okay. Now you open the linear bracket similarly as we did in the part 1 in the linear form. And for quadratic, you do bx plus c. For the whatever, which bracket has the power of 2, you open it with a numerator of bx plus c. All right?
Okay.
Okay. Okay. Now let's talk about what is a, there are 2 types of fractions, questions they can give you. They can either ask you to do a partial fraction of a proper fraction or an improper fraction. What is a proper fraction, Usha?
For example, like 1 over 2.
A proper fraction is any fraction where the numerator is lesser than the denominator. Yeah?
Okay.
Numerator is lesser than the denominator. So for these type of questions, you will look at the maximum power of x in expanded form. What does this mean? Let's look at it. For example, there's a question 3x plus 1 upon x plus 1 3x plus 1 upon x plus 1 and x plus 2. What is the maximum power of x in the numerator?
1.
Yeah?
1.
1. And what is the power of x in the denominator when I expand it?
1 as well.
When I expand the brackets.
So 2.
Yes, because there are 2 x's.
Yeah.
So if the power of the numerator is smaller than the denominator, we say it's a proper fraction. Okay? Another example of this can be x squared plus 5 upon x plus 1, 3 minus x squared. What is the power of x in the numerator?
2.
Yes?
2.
2. And what is the power of x in the denominator if I expand it?
3.
3. So this is a proper fraction because the power of the numerator is smaller than the denominator. Understand?
Yeah.
For proper fractions, what you do is you apply the partial fraction forms directly. Okay? I'll explain this to you with an example later, all right? Okay, let's talk about what an improper fraction is. An improper fraction is basically any fraction where the power of the numerator is either equal to or greater than the power of the denominator. Remember, it's either equal to or greater. For example, they give you 3x cubed plus 2x upon x plus 1, x plus 2. What is the power of x in the numerator?
4.
Yeah,
3.
yeah. And the denominator?
2.
Yes. So do you see the power of x is greater in the denominator than in the numerator? Let's look at another example. X squared plus 6x plus 1 upon x plus 1, x plus 2. What is the power of x in the numerator?
2.
Anusha, can you speak louder? I can't hear you.
2.
Yes. And what is the power of x in the denominator?
2 as well.
2. So do you see over here I've written it's either greater
Or equal.
or equal. So even if the power of x is equal in the denominator and the numerator, it will be an improper fraction. For improper fractions, there are two methods we use. This may seem like a lot of information right now, but it will be very simple when we do the questions, okay? I just want you to have an understanding of all the theoretical information before we move on to the questions. So the first method is to use long division. Remember we did the factor remainder theorem? This is why we did it. So you do long division to bring it in the form quotient plus remainder upon divisor. Okay? What is this form basically? For example, you divide 2 by 3. Okay? You do 2 ones are 2 and you get 1. Okay? So what is my quotient? What is my remainder and what is my divisor? Your quotient is basically your answer. Okay? So this is your quotient. So your quotient is 1. Then remainder is also 1 upon divisor, which is 2. So this is in the form you will express it. You see now this is a proper fraction form now. Understand?
Yes.
Yes. You'll do the same thing when you have x's in the question as well. Okay.
Okay.
And the second method is second step of the method is to apply partial fractions, partial fraction form on the proper fraction. So now when you express it in terms of this, you will only apply the partial fraction over here on the proper fraction, okay? All right. Let's look at examples now. Are you clear till here? Do you have any
Yeah.
questions still here?
No, I understood.
No? Okay. It's a very easy chapter. You just have to have a good understanding of it, okay?
Okay.
All right. Let's do examples with proper fractions right now. Okay. So the question says 2 minus x plus 8x squared upon 1 minute. One minus x, 1 plus 2x, and 2 plus x. First tell me what is the power of the numerator?
2,
2. And what is the power of the denominator?
3.
3. So what kind of fraction is this?
Proper.
Proper. Why? Because the numerator is greater than the denominator is greater than the numerator. Yes?
Yeah.
Okay. Now how do we go about this? We discussed. Now remember the first case we discussed of linear fractions? That
Yeah.
is how we will solve this question. So how we need to express 2 minus x plus 8x squared upon, there's something wrong with this. 2 minus x plus 8x squared upon 1 minus x, 1 plus 2x, 2 plus x. This is a equal to sign, which means they are completely equal, okay? We're comparing them. This is
Okay.
equal to what? A plus 1 minus x plus b plus 1 plus 2x plus c upon 2 plus x, okay? Now what we have to find out is the values of a, b, and c. Now let's understand how we find out the values of a, b, and c. So what we do is basically, the next step is to take a LCM over here. So you do an LCM. When I take an LCM over here, what will be my denominator?
1 minus x into 1 plus 2x into 2 plus x.
Yeah. Okay.
Yes.
Now what will a be multiplied with? It will be multiplied with 1 plus 2x and 2 plus x. Yeah.
Yeah.
B will be multiplied with 1 minus x and 2 plus x. And C will be multiplied with 1 minus x and 1 plus 2x. Are you clear till here?
Yes.
Okay. All right, let's look at the further calculation part. Okay. All right. Now the next step is you need to find out the values for A, B, and C. For that, you will be comparing the, can you see that the denominator is completely equal to the denominator?
Yeah.
Yeah. But for the numerator, you have to calculate it. So you do 2 minus x plus 8x squared is being compared with A 1 plus 2x, 2 plus x, plus B 1 minus x, 2 plus x, plus C 1 minus x, 1 plus 2x. One plus 2x. Okay. So you're comparing the numerators now. Okay, so this is what we're comparing now. So now the strategy we'll be using for this is, these are completely equal. So we can put in any value of x on, if we put it on both sides, so it will be equal, yes?
Yes.
Okay, so we will be plugging in different values of x. On both sides, okay? Okay, so can you see over here? If I want to find, we will take the three brackets, okay? So we have 1 plus 2x. One of our bracket is, this is my working that I'm doing, okay? I have 1 plus 2x is equal to 0. I have 1 minus s is equal to 0. And I have 2 plus x is equal to 0. The basic idea is to make one of the brackets 0 so that you can find the term. So if I plug in 1 plus 2x is equal to 0. So this will give me x as minus half. This will give me x as 1. This will give me x as minus 2. Yeah? If I plug in x as minus half, which two brackets will be cancelled out?
Two brackets?
Yes. This bracket will be cancelled out and this bracket will be cancelled out. This will become 0. Which brackets will become 0? These two brackets?
Yes.
Yeah. So I will now plug in x as minus half on both sides. Okay. The idea is to make one of the brackets 0. Okay. So you can find the term. So if I plug in x as minus half on this side, it will give me 2 minus half plus 8 minus half squared is equal to this will become 0, a into 0. This will become b, 1 minus half plus 1 minus half and 2 plus minus half. Yeah. And this will also become c into 0. Are you clear till here?
Yes.
Yes. So if a and b are becoming 0, I'm just left with a and c are becoming 0, I'm just left with b. Can you quickly solve for b and tell me?
Yeah. 9 over 4.
9 over 4. Okay, so you did, what did you get over here? 2 minus half.
Plugged in together, so.
8, yeah, you plugged in on both sides?
Yes.
Okay, great. So you got 9 over 2 on this side, yeah? What
No,
did you get
on the
on this
right
side?
side. I got on the right side. I got 9 over 4 on the right side. For B.
Alright, so you got 9 over 4 on the right side and 9 over 2 on the left side, yeah?
No, I didn't solve on the left side. Just a second.
Okay. Can you solve on the left side as well?
Yeah, minus 3 over 2 for the left. No, hold on. I'm so sorry. 9 over 2. Yes.
Yes? Okay. So if you solve this further, you will be left with b is equal to 2. Yes?
Yes.
So now we know the value for b. So I'll plug the value for b in when I'm solving for a and c now. Okay? So I have Now what will I plug in x as? Now I plug in x as 1. Okay. Why will I
Okay.
plug in x as 1? So that this bracket and this bracket can get cancelled out. When these two brackets become 0, what will I be left with? A, right? So this will
Yeah.
help me find A.
Hmm.
Okay.
Yeah.
So now let's solve for A. So I have 2 minus 1 over here on this side plus 8 into 1 squared is equal to A 1 plus 2 into 1 and 2 plus 1. And this B becomes 0 and C also becomes 0. So we do not need to write them. So can you solve for A now?
I'm getting 9 on both sides.
Yeah, so you get A as 1.
Yes.
Okay, great. Can you solve for C yourself and tell me the answer?
Yes.
What will you plug in X as for C?
Sorry.
What will you plug in X as for C?
-2.
Yes. Why -2? So that this bracket A and B get cancelled out. Yeah?
Yeah.
You need to cancel out this bracket. Solve it and tell me the answer.
I'm getting -20 over 9.
Minus 20 over 9.
Yeah.
Let me check.
No, just a second. -4.
Yeah, okay. So you will be left with C is equal to -4. Okay?
Yes.
Did you understand this?
Yes, it is.
Okay. Alright, so this is how we solve proper fractions. Let me give you an example so we can do it together now. Okay. So for example, they give you the question x squared plus 24 upon x squared minus x minus 12. What is the first step that we do always?
Check the powers for numerator and denominator.
This is not x squared, sorry. Okay. The question says x plus 24 upon x squared minus x minus 12. So you check for the powers first, yeah? So the
Yeah.
power for the numerator is 1 and the denominator is 2, showing that this is a proper fraction, yeah?
Yeah.
Okay. So what will be my next step in this question?
So this is a linear fraction. We solve it in the first way.
Okay, how will you make it a linear fraction? You will factorize the denominator,
Yeah.
yeah?
Yes. Yes. Yes.
So factorize it and tell me the factors.
4 and minus 3.
Yes.
4 and minus 3.
Anusha, I can't hear you properly.
I got x as 4
4
and
and
minus.
minus 3? Okay.
Yes.
So it will be x minus 4 and x plus 3. Yes?
Yes.
Yes. Now what do we do?
Now we write equals to, and we
Yeah.
write it for, so for, it will be a over x
Yeah.
minus 4 and
Yes.
plus b over
Upon
x
x
plus
plus
3.
3. Yes?
Yes.
Okay. Now what do? You take the LCM on the right side, yeah?
Yeah.
We do a plus x plus 3 plus b x minus 4 upon x minus 4 x plus 3. Make sure you're copying the left side as well. All right. What is the next step, Anusha?
Now since the denominators are same, we're going to
Yeah.
consider the numerators only.
Yes. So you do b x minus 4. Okay. To find a, you will have to eliminate b.
Yes.
So what will I put in x as?
4.
4. So plug in x as 4 and tell me the answer for a. What are you getting a as?
Just a second. 4.
Yes, 4. Now calculate b for me. What will you put in x as to find b?
Minus 3.
Yes. So to find b, you need to eliminate a, for which you put in x as minus 3.
B is 21.
Okay. B is 21.
Yes.
Are you sure?
Yeah.
This side will give you 21. What will this side give you? So
Minus
b
2.
is equal to minus 3. Yeah?
Um, why are we taking 4 z?
Yes?
Why are we taking 4 into 0?
You are not taking 4 into 0. What is 4 into 0?
0.
Yes. So you're basically, I'm just writing this part.
Okay, right.
Yeah?
Hmm. Yes, minus 3.
Got it?
Yes.
Okay. All right. You understand this?
Yes, it is.
Okay, perfect. Let's talk about repeated fractions now. Okay. Repeated fraction, I'm just going to talk about quadratic right now, okay?
Okay.
Let's talk about a quadratic fraction. Let me take an example. Okay. So for example, now let's be doing quadratic fractions. So you have the question says 3x squared plus x upon x plus 2, x squared plus 1. Okay. Now what is the power in the numerator? It's 2 and the denominator is 3, showing that this is a proper fraction. However, now we have a quadratic equation in the form in the denominator, yes? What do we define quadratic as? When x has a power of 2. So how do we expand this now?
So would be,
What did we, yeah?
yeah, this equation equals to a over x plus 2
Yes.
plus bx plus c over
Yes,
x
upon
square plus
x
2
squared plus 1.
plus
Yeah?
1. Yes.
Okay. Now you do the same thing. You take an LCM over here on this side. This becomes x plus 2. This becomes x squared plus 1. A will be multiplied with x squared plus 1 and B will be bx plus c will be multiplied by what? X plus 2. Okay. And this should be equal to 3x squared plus x upon x plus 2, x squared plus 1. Okay. Now you rewrite the numerators only. All right. Are you clear till here?
Yes.
Okay. Now the next step that we do is, again, we need to find out the values of x for which one of this can be eliminated. So for what value of x, if I want to find a, what is the value of x I should put?
Minus 2.
Yes, you want to eliminate bx plus c. Yeah? So you plug in x as minus 2. Can you do this and tell me the answer for a?
Yes. Is the answer 2?
Yes, the answer is true. Okay, now we have a as 2. Let's find out b and c. If I want to find, now I have a, right? So I can write 3x squared plus x is equal to 2x squared plus 1 plus bx plus c. To just make things easier for me, I write this down. Okay, now let's focus on this equation. If I want to find b, no, I want to find c. I will have to what? Eliminate what? B, yes?
Yeah.
Yeah, how can I eliminate B? Is there any way?
Multiply
What
by
can I put?
0.
Yes. So you put in x as 0 now. Okay. So
Yes.
when I put in x as 0, I'll get a 0 on this side. I'll get 2 into 1 plus b is eliminated. So c into 2. So minus 2 is equal to 2c and c is equal to minus 1. This would be your answer. Okay.
Okay.
Now you only have one unknown. You found out A, you found out B. Yeah?
Yeah.
Yeah, now you only have one unknown. So you can plug in x as any value to find out C. For example, I plug in x as 1. Yeah, for any unknown, you can find out, plug in x as any value. As long as you're doing it on both sides, it's perfectly all right. Minus 1 plus c, x 1 plus 2.
Shouldn't that be B? Or is it C?
But we found out b already, right?
Okay.
Okay,
Yeah.
no, sorry. We found out c.
Yeah.
Sorry, we're finding out b now. Plug in any value for x to find out b. So if I'm putting x as 1, it'll be 2 into 1 plus 1 plus b minus 1 into 3. What are you getting b as?
So solving.
Yeah?
Just a second, I'm solving.
Yes, yes.
Getting B as 1.
Yes. So now you can rewrite the equation as a, b, and c. How do you give your answer? What did you get a as?
2.
2 upon x plus 2 plus what is b? 1.
Yes.
And what is 3?
Minus 1.
Minus 1 upon x square plus 1. So this is your answer. You understand?
Yes.
So even in repeated roots, it stays the same, like the process remains the same. Is it easy?
I think I need a little more practice.
Yes, I will be sending you questions for practice, which you will do. And
Okay.
you can do them over the weekend. And on Monday, we will be discussing improper fractions.